Okay, welcome back. What I want to do is to continue with sorry, mathematics GCSE, okay, Key Stage 4 Open Learning Plan. Okay. Now we're going to be looking at algebra, okay. And this is what we're going to be looking at, okay. Algebra. Now the contents we're going to look at is generalized arithmetic, evaluating expressions, collecting like terms, brackets, pairs of brackets, and factorization, okay. Now it's important that you, in each of these cases, that you write out information for yourself. Make it your own. Look at how the solution has been applied so you understand the concepts in your own method and style of learning. Now this is important that you develop your own style of learning. That becomes you, okay? I am presenting you with the information and I'm presenting you in my style and method. You need then therefore to take the information, see how it applies to you, see how you can manipulate it to work in your understanding, okay? Now here we have generalized arithmetic. In this section we will look at algebra or generalized arithmetic where we replace numbers by letters, okay? Here we have a rectangle, 7 centimeters by 3 centimeters, okay? The area of this particular rectangle is 7 times 3 equals 21 centimeters square. Now, if we wanted to represent that same rectangle, we can represent it in a general format. In general, the area of a rectangle is given by area equals length times breadth. Length L, breadth B. And you already see here we have letters here already. Okay, let me just get my pen. Red don't come too good on there, so let me go with something slightly darker. Okay. Oh, come on. Okay, length times breadth. Okay, and that's what we're looking at here. Okay, that's our letter L and B. Okay, so here you can see already we have replaced numbers with letters. Okay, so bear that in mind because it's going to come up even furthermore. Okay, so here we can now say area equals L times B, and this gives it an algebraic formula. It's true for any rectangle. Okay. Here are some other formulae you may meet during your course. C equals 5 over 9, open brackets, F equals minus 32 degrees, close brackets. Now, what are we doing here? We're trying to find the degrees Celsius when we've been given the degrees in Fahrenheit. Okay? C equals degrees in Celsius, centigrade. Okay? So to find the degrees in Celsius, it's F. You do that. Sorry. Okay. Take you put c equals 5/9, open brackets, f minus 32 degrees, close brackets. Okay. Now that's why I'm telling you about you finding your own style of learning, so you can put it in your own format. Okay. A equals pi r square. Area equals area of a circle. R equals radius. And pi on your calculator will be is infinite, basically. But we take pi as normally meaning 3.142. Okay. But I know that there is some degrees where you will need a more accurate definition. Okay. X plus y plus z equals 180. And these are the angles of a triangle. Okay. Now let us consider some simple example of obtaining algebraic expressions. And this is where we are here. Okay. Okay. Now let me just move back a little bit, close a bit, because I made it quite large. Work example. Write down the number which is 5 more than x. A. B. Write down the number which is 6 less than y. And C. Write down the number which is 2/3 of z. So we're looking at that. We're looking at this. Okay. And we're looking at this. Okay. A, B, C. Okay. Now let's look at the solution to this. To find the number, we must add 5 to x. So the answer is x plus 5. Therefore, that will come out as, this is not the same as 5x. So this is not the same as 5x. Okay. To find the number, we must add 5 to x. So the answer is x plus 5. Now this is not the same as 5x. And we'll see why a little bit later on, hopefully. To find the number, we must subtract 6 from y. So the answer is y minus 6. And here again, you're seeing that we are already putting in some algebraic terms. Okay, here and here. Okay, we're bringing this into an algebraic term. Okay. To find the number, we must multiply z by 2/3. So here you can see that this now becomes this. Two z over 3. Okay. We usually omit the x sign in the final answer. And here we are, 6 more than x, okay? And if you go back, you've just done that here already, okay? You've just done that, so you will have x plus 5 in this case here, okay? But so you're going to have x plus 6 in this case here, okay? Sorry, no, sorry, I went a little bit fast there. Going ahead of myself there for a moment. Okay. Now try these for yourselves, please, okay? Do some groundwork for yourselves as well. Now, I don't want to give you the answers to these. And here, again here, we have 6 more than x. Let me just give you a little starter here of hopefully this should be x plus 6. Okay. Now you may well question this yourselves. Feel free to do so. I'm not saying that I'm always right, but I believe that to be correct. And if we look back at here, okay, and that's the idea behind this. Now have a go at the rest for yourselves, please. Okay. And work example. A man buys 12 articles at X pence each. What is the total cost? How much change in pence will he receive from £5? Solution. Extract your information first, okay? Total cost. Total cost equals 12x, because we don't know what the pence was, so, but it's 12x pence, okay? How much change in pence will he receive from £5? Right, so we have £5 in pence equal 500 pence. So we convert this to pence. So we convert let me first put that there, convert the £5 equals 500 pence. Okay, so his change is 500 minus 12 expense. That's minus the cost of the items that he had spent on. Okay, and this is where we now beginning to apply a little bit of algebra, and this is our part where we put in, make us somewhat become a little bit more algebraic in our reference. And here we are again. A woman works X hours per week for £5.50 per hour and Y hours overtime at £7 per hour. What is her weekly wage? Solution: X hours at £5.50 per hour equals 5.5 X okay, number of hours multiplied by the rate per hour, so Y hours at £7 per hour equals 7Y, so her weekly wage is 5.5X plus 7Y. Okay, now these are just bringing you into the realms of algebraic references and algebraic terms. Okay, okay, sorry about that, I was slightly distracted. So here, find the cost of meal. So here we have all solutions. Now look at the solutions, how it's been applied. Okay, the cost increases by £1.50 for each extra person. So for 6 people, the cost will be £3 plus 5 times 1.50 equals £3 plus £7.50 equals £10.50. Okay. And here you have the cost again. Okay. So look at this solution as to how this is done. Okay. Exercise. Now write these out and do them for yourselves. Look back at some simple mathematical books to see how you can resolve this. You look at any GCSE books, you'll find the work in there. Okay, you'll find these type of exercises in there. Look at what they've done. Okay, look back at what we have just done here as well and see how they have applied it and implemented and use this knowledge here to solve the questions you've been asked. Okay, there, you don't need me to be doing this out for you. This is now your game. Okay, thank you. And here we are now evaluating expressions. Sometimes you will be given values for the letters and then be asked to find the value of an expression. Okay, find the value of 2a squared b to the cube. 2a squared b to the cube when a equals 2 and b equals -1. Solution. Write out the formula, write out the part of the question for that relevance. Okay, so you then have 2 equal 2 times a squared times b to the cube. We know what a equals. A equals 2, okay? And b equals -1, because it tells us here. Let's extract a little bit of information here, okay? And again here we have a little bit of information that tells us what we're looking at and doing, okay? Here is our solution now. We know a equals 2, so therefore 2 times 2 squared times, we know b to the cube, b equals -1 to the cube. So here we have 2 squared equals 4, okay? 2 squared equals 4, and that's what we're showing you here, okay? Times -1 to the cube will still equal -1, okay? So we bring that up to here, and we can bring that along to here, okay? And that represents that here, okay? So we have 2 times 4, 8. 8 times -1 becomes -8, okay? And that gives us our answer here, okay? Make sure you understand the concept and how these were worked out, okay? Because you can see here again, we are now beginning to apply an algebraic reference. And it makes a difference. 2a squared means 2 times a squared, not 2a squared, okay? It is just the a that is squared, okay? Okay, find the value of x, y minus 2z when x equals 2, y equals 1, and z equals 3. Solution. Now you write this down first. Always write down the valuation or the question that you have been given. And here you can now begin to follow the process, okay? And as you can see here, 2 times -5 equals -10, okay? I don't need to go through that, we just did that up above, so that's now for you to follow through, okay? Now have a go at these for yourselves, please, okay? It gives you the values, look back at what we have just done, okay? Okay, and make sure that you understand that concept behind it, okay? And here are yours to do, okay? Thank you. Okay. And here we are, okay, now we're on collecting like terms. Collecting like terms, okay? An expression such as open brackets 2x plus 3x plus 5y minus x minus 3y close bracket can be simplified by collecting terms which are alike. The important rules to remember are: different letters cannot be added together. Different powers of the same letter cannot be added together. Okay? So work examples. Simplify the following expressions. And that is the one we're going to look at first. then this one, then this one, then this one. Okay. So solution A. So here we have 2x plus 3x plus 5x. So 3x plus 2x is 5x plus 5x equals 10x. And we know that is correct. Okay. B, 2x minus 3y plus 4x minus 3x plus 2y. Now, two x plus 4x minus 3x equals 3x. 2x plus 4x, that's 6x minus 3x will give you 3x, yes. And minus 3y plus 2y will give you minus, and a plus is a minus, will give you a minus y. Okay. So I'm looking at this in a different perspective for myself, okay? So let me just look at it. I'm looking at it from, no, I'm not saying that I'm right or wrong or this is the only way to do it, but feel free to look at it in your own perspective, okay? I was tempted to move these to one side, bring minus 3y plus 2y, minus and the plus makes a minus, therefore that would leave me 1y. That will leave me y. And that's how I'm looking at it. 2x (4x minus 3x) will leave me 1x. Added to 2x, which will give me 3x. Therefore, it will be 3x minus y. And I'm happy with that in my reference. So I'm just looking at it from a different perspective, and I'm looking at it from the point that 2x minus 3x leaves me 1x. Oh no, sorry. Well, let me just remove him. Let me get back to my drawing. 1 second here, recollect my pen. I'm looking at it from this point here, 4x minus 3x leaves me 1x. 3y minus 3y plus 2y will leave me 1y or y. 2x plus this 1x, and that's an x, okay, equals 3x. But that's my interpretation of it. You are free to look at it from your perspective and apply your method of solution. But I'm happy with that. It's 3x minus y. Okay? And see, again, here, look at, use this here as well. Let this be your guide. Okay? Okay. Simplify the following. Okay, these are for you to do yourself now from the solutions given above. Work them out yourself. Okay. Brackets. Simplify the following expressions by removing the brackets. Okay. And let's look at A. A should be quite simple because, well, I would say it should be quite simple because when you take this here, you have 2x plus 3. Always write out the question, okay? Always write out the question. You need to write out the question every time, okay? Do not try to solve these without writing out the question. 2x plus 3, open bracket, x minus 2, close brackets, okay? So therefore, you need to eliminate the brackets. 3 times x, that becomes 3x, minus 3 times 2, which is 6. So therefore, it's 2x plus 3x minus 6, okay? Which is 5x minus 6, and that would be your correct answer here, okay? Again here, now we have, again, write out the question. Let me just see if that was the question we were given. Yes, it was, okay? Take those out. I'll take out the brackets. 2 times x is 2x minus twice 1 is 2 minus 2. Now remember, a minus and a minus makes a plus. So that's what you need to bear in mind. 6x minus 3 minus 2x. Plus 2. Now, something here interests me. If I take 6x minus 2, that will leave me 4x. Minus 3 plus 2 will leave me 1. So, if I take, I would normally have moved these around, basically, so it became 6x minus 2x. But if I change sides, I would be changing signs. That's the thing that comes to my mind immediately. So I would have to be very careful here what I do. Because if I move this from here and move it to there, I will be changing signs. I will need to change the signs if I change sides. So, if I look at it from this point, that 6x minus 2x will leave me 4x. Minus 3 plus 2, because a plus and a minus makes a minus, that's going to leave me a minus 1. And that answer here would be correct, okay? And you're looking at taking this away from that. Those are the bits you're dealing with at the moment, okay? Then you're looking at taking this here from that. Because it's a plus and a minus makes a minus, so it has to be a minus here, okay? So be careful when you're dealing with your minuses. It's very important. It matters. Okay, and here we have the rest. The rest I will leave for you to do yourselves, okay? Let me just go back up the top. Make sure that you can see what we're doing, okay? Did I do anything there? No, yes, I did. Did I leave any marks? Did I scribble anything rubbish on here? Yes, I did. Okay, yep. Now, do not make any apologies for my scribbling on here. It's important that you understand and you're free to make mistakes. We learn by our mistakes, and it's how we rectify them that matters, okay? Do not be afraid to make mistakes or make errors. Where was I? Let me just make sure I know where I am. And I haven't passed my staging. Sorry about that. Yes, okay, yes, I agree with that. Okay, yep. These are for you to do as well. Please continue to do them. Let me just make sure I have not gone too fast ahead of myself. Thank you, okay. Sometimes one can get a bit carried away. Pairs of brackets, okay, so that means bracket on both sides, okay. And here you have brackets here, okay. X plus 2 in brackets, x plus 5 in brackets. And how do we solve this? Now, see what he's done here? He's taken this here and he's timed it x times 5. Well, let's say x times x. X plus times 5. He's then gone on to say add, taking the first bracket 2 times x plus 2 times 5. So what he's done here, he's actually used the first bracket as his multiplier. As for my terms, I will use as a multiplier to remove the brackets. Now, if you then take x times x is x squared, which becomes here, plus 5x plus 2x plus 2 times 5 is 10. And that's where we get that here. So that here is now this, becomes this, okay? Becomes that, okay? That there, a little bit, and this here, 5 becomes this. Plus, that's a plus sign here, okay? Two times x, that there now. Multiply that out. That becomes this. Okay? And that 2 times 5, that multiplied by that 5 there, then becomes this. Okay? And here we have our solution. Okay? x squared plus 5x plus 2, which is 7x plus 10. And that here is our solution to the problem. Okay. Sorry about that. Oh, hello there. Sorry.
Hello, hi sir.
Yeah.
I will come now. You know, if it's okay, if you can.
Okay. Yeah, I'll see you there in half an hour.
All right. Okay.
Okay.
Okay. Bye.
Oh goodness me. Sorry about that, guys. I'm not taking this out. I'm just not taking it out. Okay. These phone, your mobile phone always got the wrong time. It's okay. I've got the gardener coming around to do my garden, and it was raining all morning, and he just rang me now to tell me that he's coming around. Okay. So hopefully we can get it done. Anyway, my apologies for that. My sincere apologies for that. Okay. Right, but the rest of it I'm going to let you get on with for now. Okay. And you can see the solutions here. They're brilliant solutions, and this is an excellent way of learning how to get these done. Okay, expand the following. Okay, right, you don't need me to do that. You find that the principle is the same. Once you apply it and you practice, you will get these done in no time. Okay, let me just move my now factorization. Okay, and factorization is very important because you're going to do a lot of that. Okay, I'm going to be looking at this in more depth, but for the time being, look at the solution here. Look at what they've done. Look at what solution they have employed. Okay, look at the question first, and then decide how you're going to tackle it. Okay, look at what they've said. That is important. Be aware of each piece that they've applied. Okay. Look at the factors that they've moved and what they've done and how they've simplified it. Okay. I don't want to go too fast because it's important that you get this right for yourselves. Okay. Okay, right. Let me just move over so we can move this over a bit. I've made it extra big so that it's easy to be seen. Okay. Factorize the following expressions, 3p minus 6. Okay, we're not going into that. That's for you to do. Now practice. Now I hope you found this useful. Have a good day. Okay, bye-bye for now. I'm just going to work my way back up to make sure that I've got everything in frame. Okay, so bear with me, please. Okay, just so that we got everything in frame, not in flame. Okay, thank you. I'm going to have to put my teeth in, I'm sure. Okay. No, I've not, okay, good, everything seems good so far. Okay. And I'm not taking that call out, guys, just not doing it. It would mean editing a lot of, let me just go over, sure that we're in. Yes, okay. Okay, just make sure that we're up. No, I have no idea what that noise was. That's what somebody's trying to get food to me. Okay, thank you. I hope you found this useful. Have a good day. Bye-bye.